Hello and welcome back. So previously we've seen how we can implement useful functions like the adder and the flip-flops using logical gates and logical circuits. But you might wonder, how do we come up with something like this? How do we come up with the complex circuits? Well, today we're going to introduce Boolean algebra that's going to aid that process. With Boolean algebra, we can go from designing a truth table to a Boolean expression and ultimately to a logical circuit. In the process, we'll introduce a thing called product of sum form of Boolean expressions. That's going to be easier for us to derive a Boolean expression from a truth table. And then after that, we're going to introduce ways of simplifying Boolean expressions so that we can get the most efficient, meaning the least number of inputs and the least number of gates to construct a efficient logical circuit. All right, let's get started. So the first thing that we're going to introduce is what is a Boolean expression. So previously what we've seen is something like not A and B, or A or B in the most general form. So to express these, we introduce the bar over the top, which we call complement. So this term in total is called a complement to express not A. And then we have the little dot, similar to how we use the little dot for multiply in normal algebra and arithmetics to express and. So A dot B is the same as A and B. And then the same goes for the plus. It's kind of similar. It's the same sign we use in normal algebra with real numbers. But here it's similar but a different meaning. And we use the plus sign to denote and, or, sorry. We use plus to denote or, A or B. So as an exercise, try expressing all of these expressions using what we just said, the bar over top, the complement, the dot as a and plus as a or. I recommend you pause the video right now and try solving these on your own. And after that, I can show you the answers. Okay, welcome back. So let's go over these. This one is simple, like we've seen before. We just put the bar over top, saying complement, effectively giving us not x. S or R is similar, S or R. Next one, R and T, using the dot. And then not B and C, which is just not B and C. Not X or not Y, not X or not Y. The next one is not A and B. Simple, but uh, you'll get, it might come as a bit different because we aren't really used to this kind of expression, but once you get used to it, it shouldn't be that difficult. Okay, now as we have what Boolean expressions are down, let's move on to getting a Boolean expression from a truth table. So how do we do this? Well, I promised you I would introduce a term called product sums, but you'll see why it's called the product sums after we're done. So what we do here is we find the entries where Q is true, which is 1, which are these three cases, and we express them. So in the first case, we get a, sorry about that, not A and not B and not C. This is a case where Q is false, Q is true, sorry, in the first row. And the next one is we have A is true and B is true and C is false. And the next one we have is A is false, B is true, and C is true. Since all these three combinations give us a true value for Q, we can simply use an OR expression to connect them together to achieve our final Boolean expression. And now you might notice, hey, here we have expressions in the form of products, similar to real number algebra using the dot. And then after taking the product, we'll be summing the products with a or the plus sign, eventually giving us a sum of the products. And this form of Boolean expressions is called the sum of products Boolean expression. And now, as an exercise, I want you to try expressing this somewhat different but similar truth table using Boolean expressions. It should be very similar. Try applying the same process as I did before. I would recommend you pause the video right now and see the answer after trying it out on yourself. Okay, hopefully you pause the video and now I'll show you the answer. So first we find the entries where Q is true, which are these three. We express them, which the first one gives us not A and B and not C. The second one gives us A and not B and C. And the third one gives us A and B and C. And we just add them together to achieve our final Boolean expression. So in this video, we talked about how what Boolean expressions are, and we talked about how we can achieve a Boolean expression from a truth table using something called a sum of products form of Boolean expressions. In the next video, we'll be talking more about simplifying these expressions so that we can achieve a more efficient way of constructing logical circuits from these expressions. Let me know if you have any questions down in the comments or send me an email or anything. I love any feedback. Thank you.